The binary weighted ladder and the R2R ladder configurations are the two most common types of digital to analog devices now available. Both are based on current output resistor ladders. Here you see the basic binary weighted ladder DA converter circuit. Notice that it uses a simple operational amplifier with resistor feedback. It also contains a group of resistors and switching devices which can place the resistors at ground potential or at the reference voltage level. Notice that the resistor values change according to the binary system. As the resistors go from right to left, they double in resistive value. Therefore, the resistor labeled 8R will be 8 times larger in value than would be resistor R. Since resistor 8R allows the least amount of current to flow, it is designated as the least significant bit. And since resistor R, on the other hand, has the smallest resistive value, it will allow the most current to flow. Therefore, it is designated as the most significant bit. The accuracy of the DA converter circuit will depend on the precision of the reference source as well as the precision and stability of its components. Resistors, as you are already aware, change with time due to aging and variations in the ambient temperature. We will now examine a simple DA converter circuit to see how it works. Notice that this circuit consists of 8 resistors in a binary weighted ladder configuration. Each resistor is connected to a switching device which can place the resistor at ground potential or at the reference source potential. When the switch is at ground potential, no current is allowed to flow through that particular resistor. However, when the switch is moved to the reference source, a current is allowed to flow into the input of the operational amplifier. This results in the amplifier producing an output proportional to its input voltage derived from the ladder output current and the feedback resistor. As you can see from the functional table, the analog output will depend upon the sum of the inputs being applied across the ladder resistors. The full-scale output voltage of this circuit is 10 volts, and the binary input code of this circuit is in the BCD format. As you recall, the BCD format only allows digits 0 through 9 to be expressed. Therefore, the percentage of full-scale voltage represented by this circuit can only be 99%. Since this circuit generates an analog signal of one polarity only, it is often referred to as a unipolar digital to analog converter circuit. There are, however, DAC circuits which produce analog outputs in both the positive and negative sign. These circuits are often referred to as bipolar digital to analog converters. The bipolar digital to analog converter circuit uses 2 reference sources. One is positive and one is negative. A sign bit is used to control which reference source is to be switched in for a given input code. Notice that when the sign bit is 0, the output is positive going in its transition, and when the sign bit is 1, the output swings negative. The binary weighted resistor ladder circuit, however, does have problems if the bit length is longer than 8. This is due to the fact that the resistor values become much too large. For example, if resistor R is set to 10,000 ohms, then resistor 128R must be 1.28 million ohms, since it is doubled in value 7 times. Consider what happens when the reference voltage is plus 10 volts. Ohm's law shows that the current flow through resistor 128R will only be 7.8 microamps. Finding operational amplifiers that respond to input currents of this level becomes difficult unless cost is no object. In most lower-cost devices, the least significant bit current will be so low that the op-amp device will not produce a change at the output. Similarly, if you try to extend the range by making resistor R smaller, you would encounter exactly the opposite problem. As you can see, we have made resistor R 100 ohms. When we apply Ohm's law to calculate the current flow through resistor R, we see that the current flow will be 100 milliamps. This is more than most operational amplifiers can safely handle. The solution to this dilemma is to use the R2R ladder configuration. Here you see the R2R ladder configuration. It derives its name from the fact that the ladder consists of only 2 resistive values. These are the basic resistive value and a value of twice that amount. Most commercial digital to analog converter circuits will use the R2R ladder technique. Notice that this circuit also uses a feedback resistor placed between the output of the op-amp and one of its inputs. Without this feedback resistor, the op-amp would function as a comparator device instead of as an amplifier. The R2R ladder configuration also contains a group of resistors and switching devices designed to place the resistors at ground potential or at the reference source level. Since the 2R resistor furthest from the reference voltage source has the least amount of current flowing through it due to the other series R resistors, it is designated as the least significant bit. And in the same respect, since the 2R resistor nearest the reference voltage source has the highest current flow through it, this resistor is designated as the most significant bit. The basic operation of the R2R ladder network is very similar to its counterpart, the binary weighted ladder network. Here you see an 8-input R2R ladder DA converter circuit. The input data is in the BCD format. As was mentioned previously in the binary weighted ladder configuration, the highest possible percentage of output from this circuit is only 99%. The amount of current flowing into the input of the operational amplifier will depend upon the binary word input as well as the feedback current from the feedback resistor. The more current which flows into the input of the op-amp, the higher the output voltage will become. The R2R ladder configuration allows a much higher precision of digital to analog conversion since all the inputs carry comparable currents. The ideal digital to analog converter device should deliver a 0-volt output when the digital word is 0. However, due to the input offset of the operational amplifier contained within the device, a small voltage may be present at the DA converter's output. When all the inputs are a logical 1, the output should be approximately 99% of the full-scale output. When the reference voltage is 10 volts, the output should change at a rate of 39.215 millivolts for each 1-bit increment. For example, a binary input of 11001000 would cause the DAC device to produce an output of 7.843 volts. This was calculated by multiplying the decimal equivalent of the binary input times 0.039215 volts. A binary input of 100000001 would cause the device to produce approximately 5 volts at the output. Or a binary input of 000111011 would cause the DA converter to produce approximately 1 volt at its output. As you have seen, the output of the digital to analog converter circuit will depend upon the reference voltage and its binary weighted input. Digital to analog converter circuits are used extensively in today's modern industrial equipment. Before continuing this video, we will review some of the important concepts covered thus far. The digital to analog converter circuit is used to change digital quantities into a voltage or current whose magnitude is proportional to the binary input and reference voltage. The two basic types of DA converters are binary weighted ladders and the R2R ladder networks. Both are based on current output resistor ladders. The digital information placed at the inputs of the digital to analog converter may be in straight binary or in the BCD format. The resistors in the binary weighted ladder configuration double in value as they go from the most significant bit to the least significant bit. The unipolar DA converter will generate an analog output of one polarity only. The bipolar DA converter, on the other hand, will generate an analog output capable of both positive and negative output signal levels. The binary weighted ladder network is typically limited to 8 binary inputs. This is due to the fact that the value of the least significant bit resistor becomes too large. thus not allowing sufficient current to flow into the op-amp to facilitate a change at the output. Because of this limitation, the R2R ladder configuration is the most widely used of the two. The input resistors in the R2R ladder network consist of only two resistive values, the base resistive value and a value of twice the base value. The R2R ladder configuration is a much more precise digital to analog converter device since all the inputs carry comparable currents. Since the output of the DA converter is limited by the number of binary inputs, it cannot represent an infinite number of output levels. Instead, it produces an output which increases in steps according to the binary input. The resolution of a digital to analog converter is the number of discrete digital states that are used to express an analog signal. The settling time of a DA converter is the amount of time required for the analog output to stabilize after the digital input has changed. The accuracy of the DAC device represents how close the actual analog output is to the expected output. This is usually specified as being plus or minus a given bit value. The DA converter is said to be monotonic if it does not miss any of the steps across the entire range of binary inputs. This concludes review number 1.